Hey guys, welcome back. Today we're back again with the Yixiang New Energy 48V DIY battery kit. In the last video we did a comprehensive review of the battery kit and pricing, and in this video we're going to do the build. Let's get to it. Now these cells are just like the other cells I bought a year and a half ago from Ducon. These are cattle cells, 280 amp hours, but they have special terminals. Let's take a look. Okay, so these are the cattle cells that I purchased 1.5 years ago that I was planning to build with this battery. However, look at the terminals. These are the old, I wouldn't say old, but these are the welded terminals. So, very good, but look at the surface area. When you put a bus bar down on that surface area, there's not a whole lot of space that the bus bar is in contact with the stud. Now check out these. These are the ones from Yixiang. The same cells, cattle, 280 amp hours, but look at these terminals. Let's take a closer look. These actually feel lighter. Okay, so looking at the regular style welded studs, you can see the surface area right here is smaller than a dime. If you put a dime next to that, I would say it's about 40%, maybe 30% of the dime. It like basically covers the footprint of the guy's head. The indentation on the bus bar so it's maybe about 50% smaller than the dime. And check that out. Look at that. Just one of the holes cover more surface area than the other cell. See that? You can put almost a whole dime on that. Like 90% of the dime, just on one hole. So you got two holes here. So you have this much of the bus bar. You actually have special bus bars that come with the case. This is not the correct bus bar. But if it were, it would cover almost the whole width of the bus bar. And it covers like 1.5 inches. That's huge. You could put 2 dimes on that. Easily. And you got the middle section. So it's a massive surface. So really nice. So you end up with the stud having to carry the current. Yeah, check it out. Almost 1.5 inches. That is crazy. In fact, when you're using the regular style welded studs, you only have one bolt. So this can happen, right? Typically, this is not a problem because your bus bars will be locked in between the cells. But we saw in the last video with the battery main positive, main negative, the bus bar, if it came loose, it can just do this kind of number, right? But if you have a second bolt, now even the mains are locked in place. See, bus bar cannot move. Great. So observing the physical dimensions of the cell, they are identical to my older cells. However, there's a little bit of I wouldn't call it bloat. It's the way that these cases are manufactured. There's a bit of, if you press on this, there's a bit of a gap inside there. You can actually hear the electrolyte. Hear that? But when you press it together, I'm talking very little bit of force here. It's perfectly no gap at all. Versus my older cells, which are just solid. I press on these. See, I think it's a different manufacturing process. These things are just there's no give in there at all. You can't press this. So naturally, when you put them together, they're like bricks. They just go right together. Anyway, so these 2 cells we're going to set aside. We're going to use these ones to do our capacity test. We will not be installing these in the build. Okay, on the scale for the new cells, 5.5 kilograms. Alright, my old school OG cells. 5.5 kilograms. Okay, so let's do a quick internal resistance slash voltage test. 0.15. We'll just call it 0.15. It's really irritating. Okay, there we go. 0.14. 0.15. And our voltage is 3.28. So good. It's really good. So in the app, you do not use dashes. You just put the number in together. And we get cattle, LiPo 4 to 80 amp hours, 896 watt hours. Production date 17/3/2024. That's great. These were made in March. Number of cells produced 122,728. So it's 728. This is cell number 728, 122728. And this is like, this cell is 222, and this one is 225. So all your cells should be in the same batch. Let's go over to Gobble Power. In Gobble Power, you do need to put in the dashes. Okay, code seems right, code length is right. And we have the same data, March 17, 2024. Alright, looks good. Alright, so why does it matter what type of cell surface you have for your studs on your cells? Well, for one, if you're drawing high C rates, like in an electric vehicle or electric golf cart, or a solar system that relies on a single battery to supply all the current for the system. But remember, the more batteries you have in parallel, the need for these type of studs becomes less and less necessary. For example, if you had two batteries in parallel and you had a load of 100 amps, each battery would supply 50 amps. You take the total number of amps and divide it by the number of batteries. That's the load each battery will have to bear. So when we talk about cycle life, like 4,000 cycles rating on a cell, that's typically at a specific C rate. So if you're charging and discharging within those C rates, you can expect to have at least that many cycles throughout the battery's lifetime. Alright, I'm going to test these two extra cells, and while we're doing that, we're going to select 16 cells at random for the build. What's up with this? This is the problem you have. I mean, I don't know about that. Right, so a couple of those boxes were a bit sketchy, so I thought I'd go and look at the other ones. Let's take a look. Alright, so the winner here is this guy. Look at that. No stud. Of the 34 cells that I purchased, I got one with no stud, so interesting. We'll have to remedy that. But aside from that, these cells look to be in good condition. None of them have any physical damage. But a lot of the boxes, I would say 4, maybe 5, had these, when I opened up the box, the cells were just like this, or maybe the cell was even like that, and kind of lying down a little bit. That's because these cells are designed, or these boxes are designed for 4 cells. Maybe back in the day when the shipping prices weren't so outrageous, they were shipping 4 cells to a box. And then they started shipping just 3 cells to a box, or even 2 cells to a box, and you got this empty space. But what happens is, stuff starts moving around, right? And these little side supports break, and then it allows the cell to move around. And then the bag that has the bus bars and the bolts were open, and the bolts were just kind of loose, rattling around in the box. Now, what I see as a potential problem, these bus bars are quite long. In fact, they will stretch. They will span from one side of the battery to the other side, causing a short circuit. Potentially, it's pretty. It'd be pretty hard to do, but it is. You don't want these just flopping around like this. So when the top foam is on and it's covering the cells, it kind of does add some support in between the cells, so they won't move. I don't think they would move so far as to like get on top of each other, but they really should just, you know, put 2 cells to a box. That's how it came when I opened it. Same with this one. The cells were in position. The little foam separators were not broken. So most of them were like that. I would say 90%. This one too. Looks good, but these empty spaces, not a good idea. So looking at the foam, this is pretty standard. I mean, as far as the bottom capsule and top capsule, if you will. So the cell is pretty much encapsulated in foam once it goes on, right? So it's good. It's nice thick foam. The cell can just kind of flop over. And even with the top piece on, I don't know how it did, but it was able to manage to get like that sort of a position. So just to compare, this is one of the Ducon cases. So you're going to get just 2 cells to a box. And then they're just like the other ones. They're encased in this really nice foam. And those aren't going anywhere. I mean, these are solid. Mama always told me, life is like a box of lithium iron phosphate cells. You never know what you're going to get. Okay, so an update with the shipping debacle and the packaging and the cell with the missing stud. So I let them know, and they're very sorry about the packaging. They're not going to use those packaging anymore. They're going to use the 2 cell per box packaging, which is great. And they're going to ship me a new cell. And they're also going to have these cells stocked in the US, so if there's any issues with needing to get new cells, they can ship it from the US. But none of the cells were damaged, and I tested 2 so far, the 2 extra ones that I had, and I'm getting 301 amp hours out of a 280 amp hour rated cell. And that's pretty typical of a quality cattle 280 amp hour cell. You get 20 amp hours more. So yeah, 300 amp hours out of a 280 amp hour rated cell. That's really good. So these furniture moving dollies, these are great. These carpets fit the profile of this box perfectly. These are like 40 bucks, 42 bucks at Home Depot. I'll put a link down below. And they got these big casters on the bottom, and these are rated for 1,000 pounds. So technically you can put 4 batteries on these, but I don't know if I would stack it that high. I would probably do 3 max. Now we can install the epoxy board. First, we can put down the bottom pieces for the cells to sit on. Next, we can put in the side pieces and the middle pieces. These 4 pieces will go in vertically. That's it, all the epoxy board's done. Alright, so when you put your first 2 cells in, remember, this is your main positive, go into the positive terminals, and this is your main negative, go into the BMS. So we have the cell main negative over here, and we have the cell main positive over here. So at this point, we're going to take the front cover and let it down so that these aren't interfering with our battery terminals, and we can put the rest of the batteries in. So going down the line, you're going to go plus, minus, plus, minus, plus, minus, all the way down the line. So you can see we've got plenty of room in there to add our pads or epoxy boards, whichever you want to use. Just pay attention to the QR codes, it's much easier instead of trying to look at the symbols. Okay, if you did it right, you have a plus here and a negative here, so plus and minus will be right next to each other. That'll be for your jumper. You gotta watch this back epoxy board. Since there's no sticky on it, it'll fall right over. I didn't even notice when I was putting the cells in. Make sure it stays up. I better check this one. Yeah, this one's okay. Next, we want to figure out how much compression we want to apply by using our foams and or epoxy. You're going to save 2 epoxies for the front that'll go against the pressure plate, between the pressure plate and the cells at the front. Just hand tighten them, hand press them, cold pressed battery cells. It's always the way I like my battery juice. And then with a pressure plate, push it all the way towards the front. That's as much as it'll go. So we got about a ½ an inch of gap we got to fill. And my original plan was to just use epoxy board only, but I don't think that's going to work because even if I jam this whole pack, this is all the epoxy board that I have. If I jam the whole thing in here, it's not even enough room to take up that space on one side. So we're going to have to just use these in select locations, I guess. It's actually touching, but I want to add a little more. I want to get some nice compression on here. You can add a lot of compression by just, taking the bolt out pretty far. So let's put a little more in the back. So we'll go with 4 in the back. Epoxy board. Make sure you got an epoxy board against the metal. Don't have your Eva tape against the metal. It's looking pretty good on this side. Okay. Total of 4 sheets. Let's go ahead and tighten down the pressure plate. Alright, we'll start with the top middle screw. Good and tight. Yes, in case you guys didn't know, I am part German. Quite a bit actually. My last name is German. But yeah, I can't speak it though. Alright. Sorry for the shadow there. I don't know where that's coming from. Alright, so with the face plate cover back on, we're going to go ahead and bolt up the mains for now so they're not flopping all over the place. Just going to hand tighten them for now. Okay, now it's time to install the bus bars. So you're going to have 14 of these bus bars. They'll connect the batteries together. And then you'll have one fat bus bar that's going to go in the back over here. So we're going to leave this off for now. Right now I'm just going to lay them on top of the batteries. Oops. Yep. Make sure this part, the raised part, is facing upwards. Whoops. Just kidding. Remember the last one, man? I'll tell you what. It's good that these have a solid surface and the bolts can't fall through there. Alright, at this point we want to check that we have one 24-volt pack completed in series. So you're going to probe your main positive here and probe the main negative back here, and you should get around 26 volts. Alright, now we can do the other side. We're using just the ones that have the lock washers. See the difference? Either one will work fine, but I like these. It's easier to feel the torque with these. Has a better feeling to it. I don't think they come loose as easy. The other ones just kind of bite at the end, and then there's not a lot beyond that. So once that little bite comes loose, it's loose. Where these have to basically create a pressure against the head, and it takes quite a bit of turns. It could be loose, but still won't come off. Show you guys. There you go, 26 volts. Very nice. But I want to connect this back here and just check that we have 52 volts. So I'm just going to lay this temporarily right here. Always makes me nervous. Now we can probe our main positive and our main negative. This thing isn't cooperating very well. Okay, I had to put some bolts in here to get a good connection. But you can see we have 52.6 volts. So very good. Alright, so just double check that all your bus bars, the flexible hump is facing upwards. And I don't know if you noticed, but I put all the, I guess, retaining bolts on the outside of the bus bar, because we're going to use the inside holes for our balance leads or the temperature sensors. So outside, 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 outside. That's just me being OCD. Just take this one off for now. I do not want to have a live 52 volt battery at this point. Much safer when it's two 24 volt batteries. Alright, now it's time to install the PCBs. Why did you think I was going to sing that stupid song again? The PCB A, okay, it's going to go on, if you're facing the battery, right, it's going to go on the left side. It's going to be on your battery minus, okay, main negative. And the PCB with the white connector, right? The A one has the black connector. B has the white. Going to go on this side. This is the battery pack B. So this is A, and B is A 1 to cell 1 to 8 and 9 to 16. And this is going to go on this side next to the battery main positive, next to the battery positive terminals. All right. This reminds me of that game, Operation. Remember Operation? If you screw up, if you touch the sides, right? It would make this really loud buzzing sound. Does anybody remember that game? It was like nerve-wracking. Okay, looking good so far. Next we can connect up our balance leads, all the red wires. This has to read the end of the 24 volt pack. And then over here you have the balance lead. So it's kind of like a middle reference. I'm not sure exactly how the BMS utilizes this, except from maybe just checking the overall voltage between both packs, maybe. I gotta look into that more. If anybody knows, let me know. Okay, now it's time to install the temperature sensors. I went ahead and filled up all the bolt holes where I'm not gonna have a temperature sensor, so now we can just see the open ones for the temp sensors. Now, on the one-page instruction manual that they give you, they have inside, 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 and then this one, for whatever reason, they have it over here on the outside. I don't think it matters much. You could have like 2 on the outside and then 2 on the inside. Whatever you want to do, but I'm going to put them all on the inside. Okay. If you guys think I go into detail too much, let me know. Whenever I make videos, I try to I do it with keeping in mind that I could have new viewers that are, people that never built a battery before. So I know it may seem redundant if you've been watching all my videos, but there's always new people and they may not know as much. Okay. Check this out. So I was just noticing all the space there underneath the battery terminals, the positive side. You could fit an active balancer in there if you wanted to. Just keep it in there. You could fit it right down in there perfectly. So I'm going to ask them actually if they have plans to do that. It'd be nice if they welded 4 standoffs, right, permanently onto the faceplate, and then had a template board with a bunch of standoffs, so you can put, maybe 3 different kinds of active balancers onto that template and just put the standoffs where you need the mount holes instead of just, fixing it to one particular balancer. But that'd be cool because it's got the connectors right here for the balancer. So if you're going to leave it in there and do a balance every month or 6 months or whatever, you're ready to go. And now it's time for torque wrench. So they recommend 8 Newton meters or somewhere between 70 and 80 inch pounds. So we're going to do 80 inch pounds. Make sure you check with your cell type, the cell manufacturer, for the correct torque settings. That is a workout. Right, buddy? Here. Right, buddy? Remember to remove this screw right here on PCB A. Remove that screw to avoid a potential short on these 2 traces. Even this one's pretty close. That one's really close, but I think it's good. Yeah, I'm going to ask them about that. They really need to fix that. Okay, so at this point we have all the bus bars connected except for the back one there. We'll leave that until we're going to do that soon. All the balance leads are connected, all the bolts are torqued, temp sensors are hooked up. So we're ready to connect the BMS. Alright, so we still have the main bus bar on the back disconnected, so we don't have any problems while we're connecting up the BMS. Alright, so very simple. The black plug goes to the black connector on PCB A. Plug that one in first. Look at that. See that? They need to add some support underneath that. Okay. Very good. Okay. Now for the big moment. Alright, now we're looking at the back of the battery. We can connect up the bridge bus bar, connecting our 2 24-volt packs into a single 48-volt pack. Awesome. Just look how beautiful that looks. Absolutely beautiful. I want to keep the lid off. I decided to hot glue the PCB board where I removed the screws and also the temp sensors. Alright, let's power it up, see if it works. Alright, look at that. JK BMS, how I've missed thee. Alright, so it's all in Chinese. We need to change this to English. Yeah. Looks like we have an alarm. State of charge 100%. That can't be right. I think the default battery type needs to be changed. We have overcharge protection. 52.74 volts. And look at that, the delta. I like how they put the delta right on the screen. Everything you need to know is right here. Balanced, the status of the balancer, the MOSFET temperature, capacity. That's wrong, that needs to be set. And we're having an alarm over here. So let's go in the app and see what we can see. Okay, looking at the app, we can see all our cell voltages. They look very nice. You can also see it right here on the screen. And it's all in one screen. You don't have to scroll like the Ceplos BMS. It's very nice. And it looks like it can support all the way up to 28 cells on this particular BMS. So JK did a very good job with this display. Nice touchscreen display. Very easy to navigate. Default password 1 2 3 4 5 6. Cell count 16, that's correct. Capacity 280. And we need to set LiPo 4 battery type here. That should hopefully clear our alarm. Okay, the alarm is gone. But the alarm LED on the box is still lit up. I don't know why that is. I don't think it took my... Actually, I think when I reset the battery type, yeah. It took that out to default. MOSFET temp 27.6. This is the one on the actual BMS, the MOSFETs. T1, T2, T4, and T5, those are the ones inside the battery case. Next thing we want to do, we're going to flip the breaker here and we're going to test, see if we have voltage at the battery terminals. There we have it. It's at 52.92 volts. We can also see that our charge MOSFETs and discharge MOSFETs are currently on the on position. So we should be able to hook up a charger and charge the battery as well as discharge the battery. Connect up the charger and flip our breaker. It should start charging. There it goes. Alright, look at that. 9 amps. Looks like it's working. Alright, so I got a message into them trying to figure out why the alarm light LED is on and the alarm icon is displayed on the display, but there's no error. So we'll see what they say about that in the coming days. But other than that, the build is complete and so far I like it. I also told them about these screws because I got 2 different screws in my package. I got these ones with the serrated head, and I got these, they're both M6. These ones that have the lock washer and the washer, these are great for the battery terminals. And in fact they use the same terminal, right? The same screw, same bolt, except it's the M8 for all the terminals. Also, any fuse holder out there that you see will use also the lock washer and the washer. The problem with the serrated head, a couple problems. When it bites down, you get an initial bite, but once that bite comes loose, the screw can get loose, and you got basically there's no pressure there at all. The other thing, the serrade, the grooves here, cut into the balance lead terminals. So these little ring terminals, they're currently under the washer with the lock washer nut bolt, but with the serrated head, this will actually cut into that, potentially damage it or scar it at the least. So I told them to use this one only and not to ship this one. because I think these are superior in every way. A lock washer is going to hold no matter what. If there's vibration, that lock washer is going to hold and keep pressure on the bolt. But otherwise, this is pretty much a high performance setup. You got these really nice flat surfaces for these studs. You got the flexible bus bars. I mean, I am certain, absolutely certain, that this can handle 200 amps, no problem. So as you saw, I did not use any exotic tool. The only thing I had that was, I guess, exotic or something everyone wouldn't necessarily have is a torque wrench. So other than that, it's just basic tools to build this. I didn't even capacity test the cells. I just put them in the box. Other than that, the build is pretty simple. I mean, everything's pre-assembled. You could literally build this battery in under an hour. You really could. So yeah, that's all I got for this video. I'll see you guys on the next one.